Show the recording people you're so concerned for Kenny.
Yeah.
Okay, I will repeat it one more time. For Kenny. Only Kenny. Okay, so once again, remember when we're finding the domain, we're talking about the x values. Generally speaking, we're usually all real numbers, but there's two scenarios that can potentially change that. If the function has a fraction, we have to make sure there's no x value that makes the denominator 0. So that's where we take a step back there. The other scenario is if our function is a radical, we want to make sure there's no imaginary numbers. So our radicand must be greater than or equal to 0. So those are the two scenarios that sort of affect our domain. Dylan, do you think that was okay for Kenny?
Yeah, that was good.
Yeah. Should we give him a minute to finish copying?
Yeah. I think we should give him like 10 minutes.
Surely he's tired.
11.
Yeah, we should give him till 11.
Okay.
What? We should just incorporate the big.
So let's find the domain here. So what am I going to do? Obviously, there's no fraction. There will be nothing that's undefined. But we do have a radical, so we want to make sure the radicand is greater than or equal to 0. So we're going to say x plus 3 must be greater than or equal to 0. And what would do that for us? X would have to be greater than or equal to -3. All right, there's two ways to write this. If we're talking set notation, we're going to have the squiggly brackets x such that x is greater than or equal to -3. If you wanted to do the -3 is less than or equal to x, which is less than or equal to infinity, you can do it also. You could do it that way also, but this is absolutely acceptable for set notation. And then what's the other one called? This is set notation. What's the other one called? The other method? Interval notation, right? So for interval notation, we're going to have a -3 square bracket or parenthesis. Square bracket, and then where are we going to? All the way to infinity, square bracket or parenthesis. Parenthesis. Okay. Yes.
Why do you do this square bracket?
I'm sorry, I don't think I heard your question. Say it one more time.
Why do you do the square bracket?
Oh, the square bracket means that number's included in the answer. So see how it was greater than or equal to -3? So the square bracket means it's equal to. The parenthesis means it's not included. All right, so that's the domain. But I didn't just say find the domain. What did I say? I said find the domain and find the zeros. So how do we find the zeros? Well, we take the function and we set it equal to 0. So we're going to take the root of x plus 3 and we want to set it equal to 0. To undo a square, what do we have to do? Square both sides. You got it. So now we're going to have x plus 3 equals 0. So x will equal -3. What would be the point? What would be the coordinate point here? -3, 0. That's our 0. All right, next one. So f of x equals 1 over the root of x plus 3. Well, now this time we have a couple of things going on here. What do we have going on? We have a fraction, so right off the bat we know that our denominator can never equal what? 0. Right? So we can't be equal to 0. Right off the bat we know we cannot equal 0, but then because it's a radical, we can't have it be imaginary either. So not only can it not equal 0, it must also be, so it's not imaginary, greater than 0. Right? So we know our domain, we must be greater than 0. Sorry. right? We want our radicand to be greater than 0. So x plus 3 must be greater than 0. Does everyone understand why I didn't put equal to 0 here? It can't be equal to 0 because then our denominator is undefined. Then our fraction is undefined. So x must be greater than, yes. Oh, because we don't want imaginary numbers. We don't want imaginary numbers, yes.
Wait, why would it be like the first one it's greater than equal to, for this one just greater than?
Okay, so for the first one, it's greater than or equal to 0 because our radical was in the numerator. Can our numerator be 0? Is that okay? Absolutely. Our numerator is allowed to be 0. But in this scenario, our denominator is the radical. Right? And can our denominator ever be equal to 0? No. So that's why we said this one has to be greater than or equal to 0 because it can be 0. There's no problem there. But in this scenario, if it equals 0, then we're undefined and that messes things up for us.
So anytime there's a fraction, I can just put like no equal to.
So anytime it's a fraction, you want to make sure it's greater than 0. It can never equal 0. Correct. So now we have x is greater than -3. So if we're doing our squiggly brackets, x such that x is greater than -3, close our squiggly brackets. Is there a 0 here? No, there's no 0 here because we already said that x must be greater than or equal to -3. Is there anything, our numerator is 1. Is there any number that we can, or anything we can do to make that numerator 0? No, so there's no 0 here. No 0. All right, any questions on any of these two problems? All right, so now we're going to talk about sketching different functions. So I'm going to talk about standard, also called parent graphs. All right, we're going to discuss 3 different scenarios. Our first scenario or parent graph is of a parabola y equals x squared. That is our parent graph. And we need to memorize that y equals x squared is just a parabola with turning point or vertex at 0, 0. Right. Our next parent graph is y equals the root of x. And what that looks like is a shooting star, I call it a shooting star, that starts at 0. There's our shooting star. And our last parent graph it's the basis of all our shifting. So we can shift things based on other things added to this. This is going to be y equals the absolute value of x. And that's going to be sort of a V with turning point or vertex at 0, 0. Okay, now things can shift this. Things can shift this. What do I mean when I say things can shift this? So let's talk about the parabola first. If we have a parabola, it's generally in the format y equals a times the quantity of x minus h squared plus k. At this point in our sketching, the A will only tell us whether it opens up or down. At this point in our sketching, the purpose of the A is only to tell us whether it opens up or down. So we're going to say A positive opens up. Oops. Let's write it out. Positive opens up. Negative opens down. What does that mean? If it's positive, we are smiling. If it's negative, we are frowning. All right, H is going to represent our horizontal shift. And last but not least, K will represent our vertical shift. Sorry, the H has a criteria. This is only if X has coefficient of 1. I'll show you when it doesn't have coefficient of 1. All right, let's keep going. We're going to talk about the x-intercept. X-intercept. How do we find the x-intercept? Let y equal 0. And then the y-intercept, what do? Let x equal 0. So, guess what? All these rules apply for all of these graphs. So what do I mean? For the square root graph, the shooting star, you can have same format, y equals a times the root of x minus h, and then outside of the radical, plus k. Do I need to write all that over again? The horizontal shift, the x shift, it's all the same rules. All the same rules. A is whether it opens up or down, H is the horizontal shift, K is the vertical shift. And our last one, again, follows all the same rules. Y equals A times the absolute value of x minus h, close your absolute value lines, plus K. All the same rules. A tells you whether it opens up or down, H is your horizontal shift, K is your vertical shift. Are we ready to try some problems? Not yet? Okay.
Maybe like tomorrow.
Yeah, I agree.
Dylan, you get it all? Okay. So, let's go through our first example I want us to sketch. Our first one will be y equals the absolute value of x plus 3 minus 1. So we know it should be the format y equals a times the absolute value of x minus h plus k. Okay, so the first thing I'm doing is I see the absolute value lines. I'm thinking my parent function is a v, right? You guys don't have to draw this. I'm just showing you. It looks something like this. Is my a positive or is my a negative? Positive, so it's opening up. It's smiling, right? It's opening up. Okay, so we're going to stay like that. But now I'm shifting. The h tells me my horizontal shift, but it's supposed to be x minus h. The only way to get that to be a positive is if my shift were negative. That only way to get that to be a positive if this were x minus negative 3. Does everybody understand that? So now I'm shifting in the negative direction, not the positive direction. So I'm not going to shift my vertex to the right because it's a negative 3. I have to shift my vertex to the left. So I'm taking my vertex and I'm going 3 to the left in the negative direction. But then what else am I doing? I'm shifting that vertex 1 down because the K tells us the up or down shift. So now I shift 3 to the left, 1, 2, 3, and 1 down. That is now my new vertex. All right, to make this a little bit more accurate, guess what I'm going to find? I'm going to find my x and y intercepts just to have a better idea. I know it's going to look something like this, right? I know it's going to look something like that. But to get a little bit more specific here, we are going to find our x and y intercepts. So first thing we're going to do is our x-intercept. For the x-intercept, I'm going to let my y equal 0. So 0 equals the absolute value of x plus 3 minus 1. I'm going to move that 1 over. 1 is equal to the absolute value of x plus 3. Now that I have the absolute value lines by themselves, now I split it into those two equations to solve. X plus 3 equals 1 and x plus 3 equals negative 1. So x will equal negative 2 and x will equal negative 4. I'm going to plot those intercepts. So negative 2 and negative 4. What else do you think I'm going to tell you to find? The y-intercept. You got it. For the y-intercept, what do? We let x equal 0. So y equals the absolute value of x plus 3 minus 1. So y equals the absolute value of 0 plus 3 minus 1. Absolute value of 3 is just 3 minus 1. So what's my y-intercept? 2. And it looks something like that now. All right, this unit is huge on domain and range. This unit is huge on domain and range, so let's go through it. Someone tell me here, based on this graph, my domain, is domain x's or y's? X's. So which axis is the x-axis? The horizontal. So you're looking furthest left we go and furthest right we go. What's the furthest left we go, Arish? 2?
Negative. Oh, negative 4. Oh,
Negative infinity, look. Furthest left, isn't that the arrow? And what's the furthest right? Isn't it the other arrow? So it's our infinities. So our domain, I'll write it in interval notation, is negative infinity to positive infinity. All right, guys, go back. Look at our original equation. Wasn't our original equation y equals the absolute value of x plus 3 minus 1? The domain is always all real numbers. All real numbers is the infinities, right? All real numbers is the infinities. Unless there's a square root or a radical, or there's a denominator. Is there a square root or radical here? No. Is there a denominator here? No. So we knew it's going to be the infinities. Our graph just proved it. All right, so that's our domain. Now our range. Range is y's, right? All right, so now let's look at our range. You go from your lowest point to your highest point. Looking at this V, my lowest point is -1. My highest point, infinity. My lowest point is -1. My highest point are arrows, so that's infinity. Is -1 included? Yeah, so square bracket -1, comma, infinity. Parenthesis. All right, if we were writing the range in set notation, you could have done y, not x, y, such that y is greater than or equal to -1. On the test, you will not, on some you'll be given options, but on others, I will say, write this in set notation. Write this in interval notation. You need to know how to write both. All right, ready for another one?
What about the infinity part for range?
Oh, for the domain?
For range.
Oh, for range? What do you mean the infinity part?
You have to say like and.
No, because when it's saying y is greater than or equal to -1, that's going to infinity. If you wanted to write it out the full way, you could have done, which is still acceptable, y such that -1 is less than or equal to y, which is less than infinity. That's absolutely, either one of those is absolutely acceptable for set notation. We good? Okay, next one. So right off the bat, looking at this, guys, is my domain going to be the infinities or all real numbers? No, there's going to be restrictions on my domain. How do I know, Aditya, since you're talking? How do I know that it's going to be restricted? Aditya? Because there's a radical. All right, so this should fit the format of y equals a times the root of x minus h outside of the radical plus k. Not yet. I mean, this is a multi-day lesson. I don't know. You're asking too many questions. Okay, are we ready for this? So are we opening up or are we opening down? And how do you know? It's a positive A, so we're opening up. This isn't going to be a smiley because it's not a parabola, but it will be opening up versus opening down. Opening down, when I say opening down, it means like shooting star going down versus shooting star going up. So this is a shooting star going up. But now our parent graph or parent function for this looks like that. But now we're shifting our start point. Where are we shifting to? Well, this says x plus 2. The only way that's a plus is if that 2 is really negative. So where am I shifting, to the left or the right?
Left.
Left 2. Am I shifting up or down at all? No. Excellent. So now we know that's our starting point for our shooting star. Isn't that also the x-intercept? Yes. There will not be another x-intercept. How do I know that there will not be another x-intercept? Dylan?
Because there's no vertical movement, so it's just on the x-axis.
But that's not going to tell us why there's not another x-intercept. That's what happens when you copy Arish. All right, how do I know that there will not be another x-intercept? David? Yeah, when you start at the when you draw your shooting star, when you draw your parent function, it starts at whatever that starting point is, and then it's just going up. It's never coming back down again, right? So there will not be another x-intercept. But will there be a y-intercept? Absolutely. So let's go ahead and find our y-intercept. And we're going to set x equal to 0 for that. Y is equal to the root of x plus 2. Y is equal to the root of 0 plus 2. Y is equal to root 2. You will not have your calculators for this, so you have to remember how to estimate radicals into decimals. All right? I've showed you this before, yes? How to estimate it. It's okay, I'll tell you again. What you're going to do is when you have the root of a non-perfect square, you're going to pick the two closest perfect squares to it, one below it, one above it. So what's the closest perfect square below 2? 1. So you have the square root of 1. What's the closest perfect square above 2? 4. Square root of 1 is 1. Square root of 4 is 2. Now, that means the square root of 2 is going to fall somewhere between the 1 and the 2. A little bit closer to 1. So what are we going to do?
1.25.
Yeah, I would say like 1.3 or 1.25. Yeah. So all that matters to us is that it's a little less than 1.5, right? This is all just sketching. So here's 1, here's a half. We're going a little below it. And there's our shooting star. What time does the bell ring? All right, we will stop here. No homework, for real.